Section 7.1 Introduction to Discrete Probability. An experiment is a process that yields an outcome. The sample space is the set of all possible outcomes. An event is a subset of the sample space. Example, for an experiment, this is rolling a six-sided die. The sample space for this experiment is the set S of all possible outcomes, and they are, you get 1, 2, 3, 4, 5, or 6 when you roll a die. Obtaining an event. What is the event of obtaining an even number? We can describe that as a subset E of S, and T contains all even numbers from 1 to 6. They have 2, 4, and 6. Another example, randomly selecting 5 microprocessors from a lot of 1000 microprocessors is an experiment. The sample space of this experiment is the set of all 5 combinations of microprocessors. Finding no defective microprocessor out of 5 randomly selected from a lot of 1000 microprocessors is an event. Definition: let E be an event from a finite sample space S, that is, E is a subset of S. If all outcomes from the sample space S are equally likely, the probability P of E, or the event E, is defined as the quotient of the cardinality of E and the cardinality of S. Example, a Faraday's rule, find the probability of obtaining an even number. Here the cardinality of S is 6, the cardinality of E is 3. All outcomes are equally likely, so the quotient 3 over 6, which is 0.5, is the probability of this event. Example, in a lot of 1000 microprocessors, 20 are defective. 5 microprocessors are randomly selected. Find the probability of obtaining no defective microprocessors. The sample space S of this experiment is the set of all 5 combinations of microprocessors. So the cardinality of S is 5 choose 1000, and we have a formula for this. This is 1000 times 999, and we continue that way, multiplying 5 consecutive decreasing numbers, and so this is the numerator, the denominator just 5 factorial. According to this experiment, 20 microprocessors are defective, so 980 are good. The event here is the set of all 5 combinations of good microprocessors. So the cardinality of E is 5 choose 980, and the formula for this is this quotient. So the probability of E is the cardinality of E divided by the cardinality of S, and we obtain this quotient, which is approximately 0.9037. The next example, in a lot of 1000 microprocessors, 20 are defective. 5 microprocessors are randomly selected. Find the probability of obtaining at least one defective microprocessor. Of the previous example, the event now is the difference between these two sets, S and T. So, the probability of S minus C is the cardinality of S minus C divided by cardinality of S. The numerator is just the cardinality of S minus the cardinality of E. And this expression is just the cardinality of S divided by cardinality of S minus the cardinality of E divided by the cardinality of S. The first quotient is 1, and the second quotient was evaluated in the previous example. So we have this difference. So the cardinality of S minus E is 0.963. Problem. 4 microprocessors are randomly selected from a lot of 100 microprocessors, among which 10 are defective. Find the probability of obtaining exactly one defective microprocessor. The sample space consists of all 4 combinations, and there are 4 choose 100 such combinations. The event space consists of all 4 combinations from the sample space which contain 1 defective and 3 good microprocessors. We can construct any 4 combination from the event space in 2 steps. Step 1, select 1 defective microprocessor. There are 1 choose 10, which is 10 possible outcomes. Step 2, select 3 good microprocessors. There are 90 good. So the number of outcomes here is 3 choose 19, and to apply the formula for this. Then the multiplication principle applies, and we have the number of the cardinality of the event space is the product of these two numbers. Thus the probability of the event is this, and to obtain approximately 0.2996.